Okay, so next in the module 8, sorry, is graphs of quadratic functions, right? So where we're going to start looking at now is graphing, and we sort of have done that a little bit, but we're going to do a little bit more using different tools. So any quadratic or parabola, as we call them, is of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers. And a can't be 0 because if a is 0, you really just have bx plus c, which is a line. So then you're no longer dealing with a quadratic. We typically see or have seen quadratics, right? They look like a parabola. So this kind of parabolic shape where it kind of comes down and then goes up, or then up and then comes down. It can be in either form. Another form that we also see quadratics in that we have worked with, believe it or not, is f of x equals to a times x minus h squared plus k, where h and k is the vertex. So the vertex is where you have that turning point, right? So notice in the picture below, right, that's an example. There's x squared plus 4x plus 3. That's the equation or function. And when it's graphed, you notice that at the point -2, -1, there's this turning point, right? And so that's known as the vertex in this case. So, there's different ways to represent a quadratic. And so what we're going to start looking at here is how to jump from one to the other, how to identify them, and how to identify different pieces. What you'll notice also with this graph is that it crosses the x-axes, right? Those are x-intercepts there. And where it crosses the y-axes, those are y-intercepts. And so we're interested in all of that. So let's look at some examples here. So you can always find the vertex of any quadratic using this formula, negative b over 2a for the h, and k could be negative b, f of negative b over 2a, which means you're plugging it in. So let's see what that means. Here we have this example. This is in general form. F of x equals to negative 2x squared minus 8x plus 14. So if I find or define my a, b, and c, so there's a, which is negative 2, b, which is negative 8, and c, which is 14. And so then I'll have h, which is equal to negative b over 2a, or negative 8 over 2 times a, which is negative 2. What I'll end up with is 8 over negative 4, or negative 2. So now the k value in the vertex, this is going to be f of that outcome, negative 2. And I'm going to plug it back into the parabola or quadratic that I'm looking at. So negative 2 squared minus 8 times negative 2 plus 14. This is going to equal to positive 4, and negative 2 is negative 8, plus 16 plus 14. Or that will simplify to 8 plus 14, which is going to be 22. So the vertex for this parabola is the x or h value, negative 2, and the k value, 22. Right? So when you're finding the vertex, that formula is helpful there. Negative b over 2a and f of negative b over 2a. Now, the domain, we've talked about functions. Remember in module 7 we were talking about the function of a line, right? We talked a little bit about domain and range and how all that matters. Same thing with quadratics. We're always concerned about the domain and range. Now the domain of any quadratic function is always going to be all real numbers. Unless it's stated otherwise, it's always going to be all real numbers. But the range is different depending on if the graph is moving up or moving down, right? And so we kind of have to look at the graph and see and understand a little bit about that, right? So let's see how we can find stuff like that, right? So let's say we have this function, we want to find the domain and range. And right away you can just jump to the conclusion for this one and say, well, I know the domain is going to be all real numbers, right? So there's no issue there. But if you look at where the graph is starting and stopping, and we don't really have a graph, right? What you can do is you can find where the vertex is, because that's where it changes direction. And really all you need is the x value of the vertex. So let's do that. Let's find the x value of the vertex. So h, which is that x value that we're concerned with, is negative b over 2a. My a and my b are defined here. So this is negative 4 over 2 times negative 2. And that's just going to be 1. So in other words, this graph has an x value vertex at 1. Now, in the instructions above, it says to find the domain. We always said it's all real numbers, right? So we're done there. But to find the range, notice it says that if a is positive or negative, because if a is positive, the parabola has a minimum. What that means is if you looked at a graph, if it's positive, this means it's going to move like this. So it has a min value there. But if a is negative, then it has a maximum. And what that means is that you're going to have a graph that's doing something like this. And then there's your vertex, right? So in our case, we want to see what our a is. In this case, our a is negative 2. And that's less than 0. So then this means that this has a max value. Or in other words, it looks something like this right here. Right? So the range then, it's got to start right here and then it's going to go down, right? So let's find the k value here for a minute. So f of 1, that's equal to negative 2 times 1 squared plus 4 times 1 plus 2. This is equal to, it looks like 4. So the vertex is 4 and 1, and we know it moves downward, right? So it must hit its highest point, not 4 and 1, sorry, 1 and 4. So it must hit its highest point at x equals to 1, and that value is 4, and then moves on down. So the range then would go start at 4, but then it would move on down. Let's see what that means though for a graph. So let's graph this real quick. Y equals to negative 2x squared plus 4x plus 2. So you can see right away, looking at this, it hits that high at around 4 there in the range, and then it kind of comes on down, right? So it looks to me then the range would be defined as negative infinity to 4. You always read the ranges from bottom to top, so if it's all the way down to negative infinity, then it goes from negative infinity, the bottom, to the top, which is 4, and then it touches at 4. So to find the range, what you do is you find the vertex, and the k value, that's going to be your point where you stop. Now if a was positive, then you would end up having the other way around. It would just be from 4 to infinity, so just be mindful there. Okay, so that's one thing you're going to run into. Alright, next thing we have is how to graph these functions, right? So we did a graph on the on Google real quick, but we could graph these by hand. We actually have the tools to do that, right? So what we want to do is, if we're going to graph using transformations, what we need to do is rewrite this in standard form. Okay, so if we're rewriting in standard form, then what we have here is f of x equals to negative 4x squared plus 12x plus 3. I need to find a and b, and in order for me to write it in standard form, I need to find the vertex here. Sorry, I was kind of talking to myself for a minute there. But we need to find the vertex. So in order for us to put it in standard form, we need to find the vertex. Let's see what this is. And actually, let me write the standard form over here. Y is equal to a times x minus h squared plus k. So the reason why we're finding the vertex is, if you look at this formula, you have the h and the k, which are the two pieces for the vertex, and the a we're given. So if we have those three pieces of info, we have it in a different form, and we can graph it easier. So you'll see what I mean once we do that. Okay, so let's find the vertex. So the h is equal to negative b over 2a. And this is going to be then negative 12 or Yep, negative 12 over 2 times a, which is negative 4. Or this is going to equal to, it looks like negative 12 over negative 8. Or if I divide by 4, that's going to be 3 over 2. So not nice, but that's okay. K value then. This is going to equal to f of 3 over 2. So let's see what that is. So this is going to be negative 4 times 3 over 2 squared plus 12 times 3 over 2 plus 3. So here this will be negative 4 times, if I square that fraction, I'm squaring the top and the bottom, so that's 9 over 4. Plus, and 12 over 1, you can think of that as the 12 and the 2 divide out to give me 6, so plus 18 plus 3. Oh, and I didn't say this here, but negative 4 I can write as negative 4 over 1, so then those two will divide out. So negative 9 plus 18 plus 3, or 9 plus 3, or 12. So my k value is 12. My vertex then is 3/2, 12. And that means that the standard form then is y is equal to a, which we know is negative 4. We were given that earlier in the original, times x minus 3 over 2 squared plus k, which is 12. Now, when you look at this graph, here's the thing. You have a lot of information when it's in standard form, because we can see that there's transformations, right? That x minus 3/2, that's a shift to the right by 3 over 2, right? So transformation time now. This is a shift to the right by 3 over 2. We also have that it's a 4 and it's a negative 4, so it is an x-axis reflection. And a vertical stretch. And then last, it'll be up by 12 because of the outside. So that negative 4 actually does two things, right? The x-axis reflection and the vertical stretch. So let's see where we're at, right? So you always start with that base function. If we're dealing with the function like this, the base function is y equals to x squared, right? Graphing using transformations, this takes us back a bit. Y equals to x squared, right? And the base points, right, for that are 0, 0, 1, 1, negative 1, and 1, right? If you plug those in, that's what you'll get. If we shift to the right by 3/2, it's going to look a little ugly, but we'll see what that does. There's going to be 3/2. 1 plus 3/2, that's going to be 5/2. And negative 1 plus 3/2 is going to be 1/2. And then it's still going to be 0, 1, and 1. So now for the x-axis reflection and the vertical stretch, what you're doing is you're going to be multiplying that negative 4 essentially to the y values, because you're affecting the outside or the y values. So then my points are going to be 3 over 2, 5 over 2, and 1/2. But now my y values are going to be 0, negative 4, and negative 4. What I've done is I've multiplied a negative 4 to each of those. The last is going to be up by 12. So then this is going to be, my x values are still going to be 3 over 2, 5 over 2, and 1 over 2. Not nice numbers, but that's okay. And then the y values are all getting added to 12. So 12, negative 4 plus 12 is 8, negative 4 plus 12 is 8. So these are my points for my graph, right? So then let's see what that looks like. So let's say 1 is here. So then 3 halves is in between the 1 and the 2. And it's going to be 12, which just for scale, I'm going to put like 15 here and let's say 10 here. So it's about right here, let's say. The next one is 5 halves, which is about 2.5. So somewhere in the middle here. And then 8. So let me do this as 5. So it's about right here. And then 1 half and 8, about right there. And so graphing this function is going to look something like this right here. Now it seems like a lot of work to get that function, but we'll have better ways here soon.